Hi, my name is Sam, and I'm doing a chemistry workshop in the TCC Learning Commons on chemical reactions. Does anyone have any questions?
How do redox reactions work?
Okay, do you have an example redox you want to work on?
Sure. Let's see, we just went over them today. Let's see. Shoot, she didn't give us a good example of one, sorry.
Okay. Can I see
Because this is specification.
Here, I'll make one up.
All right.
So, if we have maybe, I don't know, I just look one up in the book. I don't want to make one up that's incorrect.
All right, that's fine.
Redox reactions. See something on the page. Okay, 132 redox reactions. Okay, cool. Here's one. So we have the reaction. 2 magnesium metals plus an oxygen molecule yields 2 MgO. And this would be solid. So the reason why it's called a redox reaction, is because you have something being reduced and you have something being oxidized. So they literally just took the words reduction and oxidation and smashed them together. So the way I remember oxidation and reduction is a mnemonic right over here. It's called oil rig. And what this tells you is that oxidation is a loss of electrons. And then reduction is a gain of electrons. So we just have to figure out if this is a redox reaction, that means something is being oxidized, which means it's losing electrons, and something's being reduced, which means it's gaining electrons. So the way we figure that out is we look at what's called oxidation numbers, which is basically the like the internal charge on a specific atom. So like for magnesium, whenever they don't give you the total charge on an atom, what do we assume that it is? Like, if they gave us a polyatomic ion, like phosphate, they would have to tell us that it's -3 because it has a -3 charge. But something like hydrogen, the reason why we don't write the charge is because it's just 0. So that means this is going to have a charge of 0, and this is going to have a charge of 0. So if that's the case, then that means if we have a molecule with only one thing in it, and it has a charge of 0, that means the one thing that makes it up is 0. So we would say magnesium is plus 0 or -0 or however. And then oxygen, the same thing. Since it's in its natural state and its total charge is 0, the individual oxygen atoms are also going to be 0. And then now we need to figure out what the charge on magnesium and oxygen here is. So So again, the total charge is 0, but this time it's not made of just one thing. So we can't just say this is 0 and that's 0. So what we do for this is we need to figure out, is magnesium oxide an ionic compound? And to do that, we look at the periodic table. So if we pull up the periodic table, you would see that magnesium is in group. We just draw a little periodic table. Magnesium is in group 2A, and oxygen is like over here somewhere. You have your staircase. So oxygen is on the non-metal side, magnesium is on the metal side, so it's ionic. And if that's the case, if it's ionic, we can just look at the. Well, if it's ionic and it's not a transition metal, we can just look at the row to figure out the charge. So if it's in group 1, 2, you know what the charge is? Yeah. So magnesium would be in +2 group, and oxygen have double gases and halogens and oxygens too. So it would be -2. So that means it's +2. So, in order for you to have a redox reaction, you have to have, something's losing electrons and something's gaining electrons. The way you see that is by a change in charge. So, electrons are, what charge do electrons have?
Negative charge.
Yeah. So, if we have something going from 0 positive, is it gaining a negative charge or is it losing a negative charge?
So it's going from 0 to 0? Or?
It's going from 0 to +2.
Oh, it's gaining 2.
Well, if it was gaining 2, then it would have gone down because they're negatively charged.
Okay.
So it's kind of seems backwards, but since electrons are negatively charged, if you become more positive, you're just losing electrons. So that means that this is losing electrons, which means it's oxidized. And then oxygen is just the opposite. It's becoming more negative, which means it's gaining electrons. And that's the basis of a redox reaction.
Excellent. Thank you.
Yep. I think really the most complicated questions are when they ask you the balance one. So I'm going to see if we can find one of those. And we can go through that one because balancing takes a long time. It's really it's not this one. Well, let's just balance this one. Unless you have another question you want to come.
I always said we just one room today, so it's going to be on the phone now later.
Okay. Oh, yeah, that's balancing. Balancing is really weird for redox reactions, so we just go through it. So the main way you balance redox reactions is called the half reaction method. Because a redox is reduction and oxidation. So we literally just split up this reaction into a reduction and an oxidation. So we just figured out this is 0, that's 0, plus 2, minus 2. So oxidation would be magnesium because it is losing electrons. So I just draw a big line. And now we're going to write the reaction for magnesium. So we literally just solve. Yeah, okay. So we literally just take magnesium, bring it down, and just take the magnesium ion from here and bring it down. And then before we said that magnesium was losing electrons or gaining electrons.
Losing, sorry.
Yeah,
It's
losing
backwards.
electrons is really backwards. So if it's losing electrons, that means we're going to add electrons to the product side, because this is turning into that plus some electrons. And the number of electrons we get from here plus 2 electrons. And then really the first step would be to balance out everything other than oxygen and hydrogen. That's balanced. And then to balance out oxygen and hydrogen, but this one's really simple, so we literally just add 2 electrons. And then the oxygen side. Yeah, so we need an extra oxygen, but the balance. Normally, I guess this is a bad example, because normally whenever you balance out oxygens and redox reactions, it's by adding waters. But in this case, we're just going to do 2 there, because we need 2 oxygens on both sides. Now, is oxygen gaining electrons or losing electrons? Yeah. So we're going to add 2 electrons to the reactant side because it's taking in 2 electrons. But it's each oxygen atom is gaining 2, and there's 2 oxygen atoms, so it's actually gaining 4 electrons. Because we have 2 oxygen atoms, each gaining 2, so that gives us 4. And then the last step is the oxidation and the reduction have the same number of electrons, so we can add them up. So this has 2, that has 4. What would be the least common multiple factor of 2 and 4? I think I'm using the wrong word. We want to multiply this by something to get that. So we're going to multiply this equation by 2. I know it's not, this comes down there. Painfully. We literally just distribute it to it as we can. And we do 2 mediums. 4 electrons. And then the last step we can just add them up. So everything on the left side of an arrow, so we're gonna have this, and that all on the left side. So 2 magnesium plus oxygen plus 4 electrons, and then now everything on the right side. So that yields 2 Mg plus 2 plus 4 electrons plus 2 oxygen. And then just like with net ionic reactions, anything that's on the left and the right side we're going to cross out. So the 4 electrons just go there. So,
We kind of expect it.
basically, yeah. And then that's it. Really, these 2 would combine, but yeah, that's what it is. All right. All right. Well, thank you for coming to the Chem 1045 session. We'll be here next week.
Thank you.